For this given circle U, we are asked to solve the variables x, y, and z. In order for us to solve these given variables, we need to analyze how are these variables related to one another and to other parts of the circle so that we could draw some relationships as to their measurements. First, let's talk about x. X represents this angle here. We cannot automatically say that it's an inscribed angle, even if its vertex is a point on a circle and one of its side is a chord, because one of its side is just a radius, though you could just still write here or continue to make it diameter to make it inscribed, but as of this given is concerned, we cannot automatically say that it's an inscribed angle. It's just an angle in this given figure that is formed when we are going to treat this as a smaller triangle. Y, on the other hand, is considered as a central angle, for its vertex is the center of the circle U and its sides are the radii of circle U. If this is a central angle, it has a relationship to its intercepted arc, which is this arc here. And finally, we have angle Z, which is now correctly considered as an inscribed angle, for its sides are chords of circle U and the vertex is as a point on the circle. Noticeably, the intercepted arc of angle Z is the same as the intercepted arc of angle Y, which is a central angle. In short, we are just going to use the same arc later as we look into their relationships. But first, we need to understand how to solve a specific variable that could open a process of solving the rest. I'm talking about angle X here. Because angle Y and angle Z intercepts the same arc, but this arc is unknown, therefore we cannot go into that relationship yet. What we could look into is to solve the value of variable x first. If we're going to look closely on the given figure, we have a triangle here formed by two radii and the chord which connects the endpoints of the radii as points on the circle. Let me go and have a little bit of adjustment here, as I'm going to separate the smaller triangle from the entire given. This is a similar given to this one here, but I'm making it a little bit smaller so that this we're just going to use this for analysis. Without the chords that make up inscribed angle Z, this would be our figure. You can see again that we have here a triangle forming or combining the interior angles Y, X, and an angle which measures 47 degrees. If we're going to use the concept of central angle, we don't know what's the value of it because the intercepted arc is unknown. And again, X cannot be automatically considered as an inscribed angle. But what we could use here is the relationship of the interior angles of a triangle. According to Triangle Ang Sum Theorem, it states that the measurements of, or the sum of the measurements of all interior angles of a triangle is 180 degrees. Still, we have two unknown measurements here. So where could we look into the relationship of the angles which could help us solve x, y, and ultimately z later on? Notice that the sides specifically of angle y is also as the sides of the triangle. And I'm pertaining about this side here and this side here. I already marked them as congruent because they are both radii of the same circle. According to one theorem, radii of the same circle are congruent. So this is a radius and that's a radius representing sides of the triangle, and they must be equal in measurement or congruent because they are the radii of the same circle. If this is the reality, that would mean our triangle is an isosceles triangle. An isosceles triangle is where we have two sides which are an equal measurement or congruent. And aside from that, we also have Isosceles Triangle theorem, which tells us that in an isosceles triangle, the base angles are congruent. I'm talking about this angle here as a base angle and this angle here. They are angles adjacent to the base. That's why they are called base angles. And they must be in equal measurement or congruent. In short, the measurement of angle X is just the same, being one of the base angles, is just the same or equal to the measurement of the other base angle, which is given to be this angle here, which measures 47 degrees. This is now the reality for the measurement of angle X. For, again, they are base angles of this isosceles triangle formed here, and this would be used later to solve the value of the measurement of angle Y. Because, as mentioned earlier, according to Triangle Angle Sum Theorem, if we are to add the measurements of the interior angles of any triangle, it should sum up to 180 degrees. That would mean the measurement of angle Y plus the measurement of angle X plus the 47 degrees, which is already given in the figure, must sum up to 180 degrees according to Triangle Angle Sum Theorem. And since we already have the value for measurement of angle X, we could say that the measurement of angle Y plus 47 degrees as the value of measurement of angle X plus the original 47 degrees must sum up to 180 degrees. And by solving that, we could show later that the measurement of angle Y is just equal to 180 degrees less the sum of 47 or twice 47, which is 94 degrees, which will give us a result for the measurement of angle Y equal to 86 degrees. We have now solved the measurement of angle X and the measurement of angle Y for the relationship that we have drawn from the creation of isosceles triangle using the two radii and the Triangle Angle Sum Theorem. So going back to original given, this is already 47, this is already 86, based on our computation earlier. We can now draw the value of this intercepted arc here. Why do we need to solve that intercepted arc? Is for the reason that we are also going to use that in solving the measurement of the inscribed angle Z, which intercepts the same arc. Take note that the measurement of angle Y must be equal to its intercepted arc. Let's label this with another variable so that we could use it later on. Let's say W is just equal. As for central angle and intercepted arc, it's just equal to each other. So since the measurement of angle Y is 86 degrees, the value of the arc, which we label as W, is also 86 degrees. Now we have this intercepted arc and in the structural angle Y, which is also this intercepted arc of the inscribed angle Z. So we could use the value of W, arc W, as 86 degrees to solve for the measurement of the inscribed angle Z, for which we know that the measurement of any inscribed angle, in this case Z, is just equal to half the measurement of the intercepted arc W. So the measurement of angle Z is half the measurement of W, which is 86 degrees. In short, the measurement of angle Z is equal to half of 86, which is 43 degrees. We have solved all three variables, including one of the variables we've added, which is the arc, intercepted by two angles, the inscribed angle Z and the central angle y. This is how we solve the unknown variables for this given circle U.